So here we are going to be graphing a couple of these polar curves. I posted this on Canvas so you can kind of take a look at this. And it basically tells you the basic shapes of all of these guys. And then I'm going to show you how to graph them using a reference graph and then being able to graph it on polar paper. So I'll show you how to do that. But this is basically what the four different types that we're going to be looking at. Um, uh, Keep in mind we have this last one. I don't think we're going to be really talking about this last one, but I'll kind of tell you a little bit of what this is, the lemon skate or the lemon scats. Okay. So the first type of polar graph is basically the circle and the spiral. So if you think about the circle, if you have an equation that looks like r equals a, so for example r equals 3, like we saw in this previous video, then all that's going to give you is a circle of whatever that radius is. So basically, in order to graph something like this, well, everything is going to be of radius 3. Okay, and then you're just going to draw the circle, whatever the circle may look like. Okay. If you have the number attached to the sine, then basically you're going to have that radius, but this circle is not going to be in the center. It's going to be hinged, and it's going to be grabbing the x-axis. Okay, so if I had 3 sine theta, then you're going to have a circle of radius 3, and it's going to be hinged about the x-axis. If I had cosine, then that one is going to be about the y-axis. Okay. All right. So one way that I can kind of remember that is that the cosine is the x value, so it's going to be about the about the x-axis, and then sine is the y value, so it's going to be about the y value, about the y-axis, the positive. If these were negatives, they will be swapped. Okay. And then finally, if let's say you don't have a cosine, instead you have like something with theta, like 3 theta, then basically what you're going to end up getting is kind of like this weird spiral, which we call the Archimedes spiral, and it keeps going. Okay, so that's what we get. All right, so that's the first kind of cases. The next case is a limacon. Okay, and this is not a C, it's a soft C, it's a French, so it's a limacon. So basically, it really these are kind of like the forms in which the limacon kind of exists. And obviously the orientation will depend on the sign of B. So basically, if B is much greater than A, you're going to have this little loop, a limacon with a little loop in the center. And I'll show you what that looks like. And then you have these other cases, which I never really remember. I just graph them. And I'll show you how we can graph. You don't have to memorize any of this. When I do the graph, you'll immediately know how to which one is which. So you have this cardioid, which kind of looks like a heart or like a butt. I don't know how you want to say it. But if A and B are the same, then you kind of have this little heart shape, which is called the cardioid. And then you have the dimpled limacon and a convex limacon. I don't really care. I mean, those up here, but I don't remember when if A is greater than B, you're gonna get this. I just go ahead and graph it. But these are basically the equations of limacons. Okay, and this is the cardioid. And then you have roses, so rose curves. So usually the way that you get roses is that the number, you have a sine and a cosine, and then you have n inside of it. So you have an altering of a period. So if n is odd, then you're going to have n leaves. And if n is even, you're going to have 2 n leaves. So for example, if you look here, I have 2 theta in here. That means you're going to have double the amount. So you're going to have 4 leaves. If you have 3, which is odd, you're going to have the same amount of leaves, which is 3. If you have 4, then you're going to have 8 leaves, and so on and so forth. And you can kind of see that, and you'll usually the cosine is right on the axes. Okay, so see how all of these are, at least in the beginning, they start off right at the axes. The sine curves are off, so they kind of are on the quadrants. If I were to draw the rose curve like this. Okay, and then you have lemon skates, which if we get to them, we'll get to them. All you really need to know is that they're basically squared in the front. Okay, so these are very useful, and you're going to be doing a lot of area problems in calculus too. So, but right now, all we really want to know is how to graph them. I'm going to just show you how to graph. So we're going to do at least one for each of them. We're not going to do all of them, just so that you can kind of get a glimpse of how to do them. So we're going to start, the way that I'm going to do it is not really using these formulas. We're going to kind of predict what the graph would look like, and then we're going to go ahead and graph it. So the way that I'm going to do it, we're going to start off with a spiral. So let's say we want to graph r is equal to 2 theta. The way that I do it is that I want to start off with a reference graph. So basically, I'm going to graph this guy in x and y. So let's say this is going to be the theta, and this is going to be the r. Okay, so the way that I do it is that I want to go ahead and plug in a couple points. So I'm going to start off the way that we kind of start off with the angles, which is a quadrantal angle. So it's going to be 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So that's kind of how I want to start off. So first we're going to start off by plugging in 0 into theta. So if we plug in 0 in here, I'm just going to get 0. So the radius will be 0. If I plug in pi over 2 in here, I'm going to end up getting pi. If I end up plugging in pi there, I'm going to get 2 pi. If I end up plugging in 3 pi over 2 in there, I'm going to get 3 pi. And then if I plug in 2 pi in there, I'm going to get 4 pi. So you can kind of see that this is kind of like a linear relationship. So this kind of goes in a straight line. Okay, so obviously in the negative side, if I chose negative angles, it would go the opposite direction. Okay, so now that's my reference graph. And the way that I'm going to graph this, now let me graph it into the polar form. Okay, so now switch it to polar. So now what I'm going to do is I'm going to look at each of these angles. So I'm going to look at theta equals 0, theta equals pi over 2, theta equals 3 pi over 2. Oops, that's wrong. Theta equals pi, theta equals 3 pi over 2, and then theta equals 2 pi. All right, so let's see what happens. So we're going to start off with the first angle. So at angle theta equals 0, I have a radius of 0. So basically, I'm at the pole right there. I'm at the pole. All right, so now as I go to pi over 2, okay, what am I going to go to? So I'm going to go to pi, and pi is about 3.14. So that means in this direction, at pi over 2, I'm going to go up pi units in this point. So in order for me to get from here to here, I have to somehow curve, because there's some angles in here. You can see that this is kind of curving. It's going in a positive direction, so it's going to kind of curve a little bit from there to there. Okay? And then what I'm going to do, I have to go to pi. And at pi, notice that I'm at 2 pi. So 2 pi is about 6 point something. So it's a little bit further away. So in this direction, in the pi direction, at theta equals pi, I'm going to get 2 pi. So from here, I have to reach to the next one. So it's going to curve that way. Okay. Then at 3 pi over 2, you can see that now I'm at 3 pi. So 3 pi is now further back down. Okay. Out here in the direction of 3 pi over 2. So now I'm going to continue curving. Okay, and finally at 2 pi, I'm going to be at 4 pi. 4 pi is way out here. And now I'm going to continue curving to that point. Okay, so this is the spiral. So basically, when you're graphing in polar form, you're having these weird curves, because remember, you still have angles in this direction. In this angle, you have a certain radius, right? So in all of these angles, you have some sort of radius that are increasing and increasing. That's why these guys are increasing. So it's kind of curving. Okay. All right. So that's how you graph the spiral. Okay. So now let's do another problem. So let's say we want to graph this one, r equals 2 sine theta. Okay. So we're first going to start off by graphing this as a reference. So notice that there is no amplitude, there's no period change. So it's going to be 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And then notice that it's an amplitude of 2, so everything's going to be up by 2 units. So sine starts at 0, 2, 0, -2, 0. So this is how the graph basically looks like. Okay, and you can kind of already predict of what this graph is going to look like, because if you look at the little cheat sheet, you can see that this is just going to be a circle. Okay, so let's go ahead and graph this. So now let's graph it in polar. All right, so we're going to start at theta equals 0, then pi over 2, then pi, then 3 pi over 2, and then 2 pi. So starting at 0, okay, at theta equals 0, I'm at the pole 0. That's at that point. Then at theta equals pi over 2, what's the radius? The radius is going to be 2. So I'm going to go up 2 units, and I'm going to curve that way until I get to 2. Okay, and then I'm going to go to pi. And what happens at pi? At pi, this pi, I'm going to go in this direction. I'm going to go to 0. So that's basically here. So from here to here, I'm going to go to 0. I basically already completed the graph, because, and be okay with that. Sometimes you might complete the graph before you complete everything. So if you want to continue on, you can see that at pi, 3 pi over 2, which is in this direction, where are you going? You're going to -2. That means you're going in the opposite direction. So I ended up here. Now I had to go back up here. So then I basically trace it again. Okay, and then finally I go back to 2 pi. 2 pi is this guy. Then we're going to go back to 0. So you basically trace the circle twice. Okay, so you kind of have an idea. What I want to see in the exam is make sure that you graph your reference curve and then graph the polar curve. Okay, so now let's do another one. So let's say you want to graph r is equal to 2 plus 2 cosine theta. Okay, so you can see that 2 plus 2 cosine theta is going to give you this guy, a cardioid, because A and B are the same. So they're going to look something like this, depending if you have cosine or sine. Okay, so let's go ahead and start off by drawing the reference graph. Okay, so it's going to be 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Now, we all know how to graph, so I'm just going to go ahead and just do it. 1, 2, 3, 4. So I'm just going to go ahead and tell you what this graph is. The graph looks like. Okay, we've done this already, so this shouldn't be a surprise. Okay, now let's go ahead and graph it. So we're going to do theta equals 0, theta equals pi over 2, theta equals 3, why do I keep doing that? Okay, theta equals pi, theta equals 3 pi over 2, and then theta equals 2 pi. Okay, so we're going to start off with 0. Notice that this time it's not going to start at 0. It's going to start at 4. So at theta equals 0, you're going to be at 4. 1, 2, 3, 4. So that's where we're going to start. Okay. Then we're going to go to pi over 2. And at pi over 2, you're going to be at 2. It's going to be 1, 2. Okay. So you're going to go from here, and you're going to go all the way to 2. Okay. So notice that the radius is getting smaller and smaller. So they're going to 3, and then it's going to go rapidly to 2. Okay. Then at pi, which is in this direction, you're going to go back to 0. So from here to here, you're going to get smaller and smaller radii from 2 to 1. So we're going to go all the way to 0. Then at 3 pi over 2, notice that this is basically the same shape as the other guy, so there's some symmetry, and it's going to go to 2 at 3 pi over 2. Okay, I'm just going to write just 2. Okay, so I'm going to go back to 2 at this direction. And then finally, it's going to be the same shape as this side, and I'm going to go all the way to 4. So to 2 pi over 2 pi is going to go all the way to 4. So you kind of have this heart shaped along the x-axis. Okay. All right. So now let's do 2 more. We're going to do a limicon, and then we're going to do a rose curve. Okay. So let's do one with a limicon where you have r is equal to 1 plus 2 cosine theta. Okay. So we're first going to start off by drawing the reference graph. So it's going to look something like this. So the period hasn't changed, so 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Notice that the amplitude is going to change by 2, and then there's going to be a vertical shift by 1, so it's going to look like this. And if you see in the previous one, you can see that your B value is going to be greater than your A value. So you're going to have something with the loop, okay? Now you have to be very careful here because when you have graphs that look like this, you need to pay attention to where it goes to the x-axis. So notice here that there's 2 points where this crosses the x-axis, somewhere between pi over 2 and pi, which is basically in quadrant 2, and then somewhere between pi and 3 pi over 2, which is somewhere in quadrant 3. So there is an angle here where this crosses or goes to 0 before it goes to pi, or before it goes to 3 pi over 2, okay? So we have to keep those in mind. So let's go ahead and graph this in the polar form. So we're still going to say theta equals 0, theta equals pi over 2, theta equals pi, theta equals 3 pi over 2, and then theta equals 2 pi. So starting off with theta equals 0, we notice that there's going to be a 3. So we're going to have 1, 2, 3. So that's where this guy's going to be at. All right. Then we go to pi over 2. At pi over 2, we're going to be at a 1. Okay, so we're going to go from here all the way to the 1. Okay, now right before I go to pi, there's going to be an angle in quadrant 2, whatever that angle may be. I'm going to call it theta 1. And at that theta 1 value, it's going to go to 0. Okay, so I'm going to go to 0 here at this particular angle. Okay, goes to 0 in this direction. Now at theta equals pi, where am I at? I'm at -1. So -1 is not this way, it's the directed distance, so it's going backwards. So here is -1. So now I'm going to go from here to here to -1. Then I'm going to go back to 0 at another angle. So there's another angle here, theta 2, where this is going to go back to 0. So now this guy, this angle is going to go back to 0, which is right here. Trying to make it a little symmetrical. Then at 3 pi over 2, notice that I'm going to go to 1. And so in this direction, I'm going to go to 1. So from 0, I go to 1. Oh, God. Okay, so I'm going to go to 1. And then finally at 2 pi, I'm going to go back to 3. So to finish the entire loop. So you can see that if I didn't do that, I wouldn't have gotten this loop. I would have gotten something completely different. Okay? All right, and now let's finally do the last one, which is basically the rose curve. So that guy that I just did was a limacon. We did a cardioid, we did a spiral and a circle. So now we're going to do a rose curve. So let's say we want to graph r equals sine 2 theta. Okay, so notice that there's a period change here. So we're going to have to say that theta is going to be between 0 to 2 pi. So that means that if I plug in the 2 theta in there, then that's going to change everything up. So now theta actually is a little quicker. It goes from 0 to pi. So what you want to be able to do is when you graph this, you don't only just want to go to 0 to pi. You want to go still all the way to 2 pi. So first let's figure out what these values should be. So this should be pi over 2. This should be pi over 4. This should be 3 pi over 4. Okay, and then we're going to complete it until we get all the way to 2 pi. Okay, so we still want to make sure that we complete it all the way until we get to 2 pi. Okay, so halfway between this point will be 3 pi over 2. Halfway between this point will be 5 pi over 4. Halfway between this point will be 7 pi over 4. Okay, so this we completed kind of the whole cycle. And the reason why we don't want to go all the way to pi is because you might not complete the entire leaves. You might have it incomplete. So you want to make sure that you complete all of it. So there's still an amplitude of -1 and 1. And then we're just going to graph the sine curve. So you can kind of see that it's going a little bit faster. Okay, so it looks like this. It is a sine. Thought it was cosine. All right, so it looks like that. So completed 2 periods. And now let's go ahead and graph it. All right, so first we're going to start with theta equals 0. At theta equals 0, it's 0. So we're done there. Then we're going to go to theta equals pi over 4. So theta equals pi over 4 is right in the center at 45 degrees. And at theta equals pi over 4, we are going to go how many units? 1 unit. So let's pretend that this is 1 unit. So this is 1 circle. So imagine that there was a circle here. This would be 1 circle. So from here to here, you're going to go to this guy. Okay, 1. Then at pi over 2, theta equals pi over 2, we're right here in this side. We're going to go to 0. So this guy just goes back to 0. All right. Then we're going to go to 3 pi over 4. So 3 pi over 4 is going to be right here, right in the middle. And in that direction, what are we going to do? Well, in that direction, we're going to go -1. Okay, so now -1 is not there. It's on the opposite side. So -1, if I say that's -1, then it's going to go from 0 all the way to this guy. Oh, I think I made it too big. It doesn't matter. Okay. And then when I go to theta equals pi, I'm going to go back to 0. Okay. So notice that if I left it at pi, we would have only gotten 2 petals and we wouldn't be done yet. Now we're going to go to 5 pi over 4. 5 pi over 4 is right here. So theta equals 5 pi over 4. We're going to go in that direction 1 unit over. Okay. And then we're going to go to 3 pi over 2. And we're going to go back to 0. And then finally, we're going to go to 7 pi over 4. 7 pi over 4 is around here. But in that case, we're not going in this direction. We're going to go the opposite direction. And in the opposite direction is going to be -1. So we're going to go back up. And then finally, we're going to go back to the other side. Okay, and then that completes the graph. So usually when you're graphing something like this, it's really easy to just figure it out. Now, sometimes when you get like sine of 3 theta, and you go ahead and try to complete this guy to find the periods, you're going to end up getting like 0 all the way to 2 pi over 3. Sometimes it can be really nasty to work with radians. So if you want, you can always change it to degrees. You can do 0 to 360 and then change this to the degrees instead, because that might be a little bit easier to work with. 0, 90, 180, 270, and 360. So sometimes this might be a really good idea, especially if the radians get really nasty. In this case, the 2 was fine, but notice that because this was even, you had an even number of petals.